Okay, to use JASP to analyze the difference between two proportions, this will be a little bit different. And actually, we won't use everything on this. What you'll see next week is the two proportion z-test is the subset of something called the chi-square test. But here's how to go through for what we need right now. File, open, navigate to the file that you want to open. And so we have here organization, retail, or civil service, and then whether or not they viewed the performance appraisal as unfair and not transparent. So we're really with two categorical variables, just looking at frequencies. So I'll select frequencies here. We're actually going to do something called a contingency table, which will be a table where you have retail and civil service in one side, and then yes or no for the unfair on another. And I'm just going to have rows and columns here to select those and put them in rows and columns. So what you have in the first row here is of a total 200 in civil service, 136 said yes, and in retail, out of 200, 124 said yes, and of course then 76 and 64. So for our sample size, all the yeses and nos have to be greater than 10, and there they are. 64, 136, 76, and 124. Those are all greater than 10, therefore we have a large enough sample. And then you can see down in the bottom here, it's not going to say two proportion z-test, it's a chi-square test, but it's going to have the same p-value that we had when we calculated the two proportion z-test on our calculators. So you can get the p-value here. It's not going to do the confidence interval. You'll need to do that on your calculator or using formulas. And let's see here, under the statistics, I'm going to select phi and Kramer's V. This is just going to give us our effect size. You can see over here it has a confidence interval, but that is for odds ratio, not proportions, and we're not going to do that in this class. And you can see they have some other things over here. We won't be doing those, although I will say the continuity correction actually gives a slightly more accurate view of things. But if we just do the plain chi-square, that's going to line up with what you'll see in introductory texts and also what our TI calculator does. So I'm going to select this, and you can see the phi coefficient and the Kramer's V, they're the same in this case. But the phi coefficient is used when you have a 2x2 table, and what the chi-square test will do is when we have more than two categories in each one, and that'll be next week. So for example, if we had civil service, retail, and manufacturing, now you can't do the difference between two proportions, you actually have three, and of course you could even do a 3x4 table or something like that, but again, that's next week. But this phi coefficient is 0.063, and you can use the table to decide which kind of, how large of effect. In this case, it was negligible effect. That's it for using JASP for categorical variables. Now, if you need to do a bar chart or something like that, you'll need to, at this point, do that in R proper. I suppose as JASP develops, then it will add more and more graphics. They're just not there